Have you ever stopped to wonder what the atomic weight of carbon could possibly have in common with, say, the most advanced AI chatbots? I know, it sounds kind of like a trick question, right? But the answer is this single, incredibly powerful idea that scales from the tiniest atom all the way up to artificial intelligence.
Okay, so to get started, let's rewind back to high school chemistry class. We all learned that carbon has 6 protons and 6 neutrons. That should add up to an atomic weight of exactly 12. Simple enough. But if you look at any periodic table, the number is always 12.011. So where does that little extra bit come from? Well, the answer to that is the key to everything we're talking about today.
All right, so let's really dig into this. To solve this whole puzzle of that 12.011, we've got to understand something super important. Not all carbon atoms are actually the same.
So the secret here is a little something called an isotope. Now, an element is defined by its number of protons. Carbon always has 6, that's what makes it carbon. But the number of neutrons, that can change. You can think of isotopes as, different flavors of the same element. They're all carbon, but some are just a little heavier than others.
So out in nature, you've got two main stable kinds of carbon. The vast majority is carbon-12 with its classic 6 protons and 6 neutrons. But about 1% of all the carbon out there is actually carbon-13, which has an extra neutron, making it just a little bit heavier.
Okay, so if you've got these two different weights floating around, how in the world do you get just one single number for the periodic table? It's not as simple as just, adding them up and dividing by 2. No. What's really cool is how chemists use a specific kind of average, one that takes into account how common each isotope actually is.
And here's the raw data. Check this out. Carbon-12 makes up nearly 99% of all carbon on Earth. Meanwhile, the heavier carbon-13 makes up just a little over 1%. The whole goal is to combine their very precise weights into one number that really represents the whole group.
The whole process is called a weighted average. And honestly, it sounds way more complicated than it is. It's really just a simple two-step thing. First, you take the weight of each isotope and you multiply it by its abundance. Then, you just add those two results together. That's it.
And boom, here's the crucial insight. This is the whole thing. The final average is pulled very close to 12. Why? Well, simply because the carbon-12 isotope is so much more common. That tiny 1% of the heavier carbon-13 is just enough to nudge the average up ever so slightly to 12.011.
And there you have it, 12.011. So that number you see on the periodic table, it's not actually the weight of any one single atom. It's the weighted average of all the carbon isotopes, a number that reflects what you'd find in any typical sample. Our little puzzle is solved.
I love this quote. It illustrates the concept perfectly. It's kind of a funny way to think about it, but it really makes the point, doesn't it? The average is a calculated representation. It doesn't mean any single thing in the group actually has that value.
Okay, now, let's take that simple idea and just scale it way up. Because this same concept, calculating a weighted outcome based on how common different inputs are, it's not just for chemistry, folks. It is the absolute bedrock of modern artificial intelligence.
At its absolute core, machine learning is really all about making predictions. Instead of a programmer writing a bunch of explicit rules, an algorithm learns from huge amounts of data. It finds the patterns so it can figure out the most likely outcome. It's all about weighing the evidence.
Now, broadly speaking, you can think of machines learning in a couple of ways. With supervised learning, you give it labeled examples. This is a cat, this is a dog. So it can learn to predict labels for new stuff. With unsupervised learning, you just dump a pile of data on it and say, hey, you figure out the patterns and groups on your own.
And right here, this is the direct connection. This is the bridge. Just like we weighed the abundance of carbon-12 and carbon-13, a machine learning algorithm weighs all these different pieces of evidence, which we call features. So, to predict a house price, for instance, it'll probably weigh the square footage really heavily, and maybe the color of the front door not so much.
All right, now let's take this whole concept to its absolute mind-bending extreme. Large language models, the tech behind chatbots like ChatGPT, they are without a doubt the most powerful weighted prediction engines ever built.
So when you type a question into a chatbot, it's not thinking like a person does. Nope. It is performing a truly massive calculation to predict the next most probable word. It's already looked at trillions of examples of text to learn the statistical weight of every word in relation to every other word. Here's a way to picture it.
Imagine the model is this gigantic, impossibly complex machine with literally hundreds of billions of tiny dials. We call them parameters or weights. The whole training process is just about adjusting these dials over and over and over again until the machine gets really, really good at predicting the next word correctly.
The scale of this is, well, it's just really hard to wrap your head around. But to put it into perspective for you, if you could somehow perform 1 billion calculations every single second, it would still take you over 100 million years to do the math required to train just one of these models. It's just staggering.
So there you have it, the very same principle, a simple weighted average that explains a little quirk on the periodic table, is the exact same one that, when you scale it up with computers to an unimaginable degree, allows an AI to write a poem or answer your deepest questions. And that leaves us with this really fascinating, kind of deep final question. If it's all just a sophisticated calculation of probabilities, one massive, complex weighted average, can we really say that an AI truly understands language? Or is it just an incredibly convincing mimic? What do you think?